Hey guys, all right, we're back. So now we're going to work this problem, okay? So solubility in KSP example. So let's read it. So solid silver chromate is added to pure water at 25 degrees Celsius. Some of the solid remains undissolved at the bottom of the flask. What's the purpose of them telling you this? They're telling you this because they know that it's at equilibrium at this point, right? That it's a saturated solution, because they're telling you again, the mixture is stirred for several days to ensure that equilibrium is achieved between the undissolved solid silver chromate and the solution. So this is a saturated solution. This is a saturated solution that's at equilibrium, okay? So analysis of this solution shows that the silver ion concentration is 1.3 times 10 to the minus fourth molar. Assuming that the silver chromate dissociates completely in water and there is no other important equilibria involving the silver ions and the chromate ions in the solution, what is KSP? All right, so now let's go to our handy dandy piece of paper. All right, here we go. So let's write the expression first. So we know our compound is silver chromate, okay? So, and I'm going to write out the dissociation so you can see it. So we have silver chromate, and this is a solid, and this is going to dissociate into two silver ions plus the chromate ion, which is a 2- ion. And both of these are aqueous. I know I didn't write that before, but okay. So they're both aqueous. All right. Now, what's the KSP for this? Okay. So KSP is going to be equal to the concentration of the silver ion squared, right, times the concentration of chromate. Now we know what one of those concentrations is. Now we have to know them both if we want to solve for KSP, but let's start with the one we know. We know that the silver ion concentration is 1.3 times 10 to the negative fourth molar. Okay, so KSP is equal to 1.3 times 10 to the minus fourth squared times, we got to figure out what that is. Okay? How do we figure out what that is? Well, if we have 1.3 times 10 to the minus fourth molar concentration of silver ions, we're going to use stoichiometry to relate the silver ions to the chromate ions. What's the stoichiometry I'm talking about? I'm talking about the coefficients in this balanced chemical equation. Divide by what you have, multiply by what you want. For every 2 silver ions, there is 1 chromate ion. So basically what we need to do here is we need to take this 1.3 times 10 to the negative fourth, and we got to divide it by 2. All right? So let's do that. Using our handy dandy calculators. All right. So 1.3 e negative 4 divided by 2 is 6.5 times 10 to the negative 5. So 6.5 times 10 to the negative 5 molar. So that'll go here, 6.5 times 10 to the negative 5. And we just need to multiply across. So again, just handy dandy calculator. 1.3 e negative fourth squared times 6.5 e to the negative fifth. And we get we need 2 sig figs, so that's 1.1 times 10 to the negative 12th. Remember, this is KSP, so it is unitless. Okay, KSP, so it is unitless. All right, and if we go back to the slide, we should get it right. Ta-da! Very good. All right, so everybody gets this one. Let's do the next one. Moving on. All right, so a saturated solution of magnesium hydroxide in contact with an undissolved solid is prepared at 25 degrees Celsius. Let me just clarify. The reason they keep saying this is because if you don't have it in contact with undissolved solid, how do you know it's fully saturated? That's why they're saying that. So the pH of the solution is found to be 10.17. Assuming that magnesium hydroxide dissociates completely in water and that there are no other simultaneous equilibria involving the magnesium ion or hydroxide ions in solution, calculate KSP. Why are they saying all the crap at the end of the question? They're basically saying hey, just worry about what you see. Don't worry about those ions interacting with water. Because remember, water auto-ionizes, and if those suckers are interacting with the auto-ionization of water, that's a whole nother nightmare that you got to worry about, right? But they're telling you, don't let that nightmare get to you. Focus on this. All right, so again, we're trying to get KSP, but they didn't give me any concentrations this time. Ugh. All right, let's figure it out. Okay, well, we know we got magnesium hydroxide. Let's start by just writing our dissociation question, or dissociation reaction. All right, so magnesium hydroxide, which is a solid, is going to dissociate into the magnesium 2+ ion and 2 hydroxide ions. Okay, I know that right off the bat. I can write the K expression. I know that KSP is going to be equal to the magnesium ion times the concentration of the hydroxide ion squared. Now, the only other piece of information they gave me is they told me that pH is equal to 10.17. Now, at this point, hopefully you're starting to see maybe how we can figure this out, right? Because we can relate pH to POH, and then POH to hydroxide concentration, and then relate hydroxide concentration to magnesium concentration. So a lot more work than the last question, but it's still doable, all right? So POH is equal to 14 minus pH, so 14 minus 10.17, okay? 14 minus 10.17 is 3.83. Okay, now concentration of hydroxide should be equal to 10 to the 10 to the minus POH, so 10 to the minus 3.83. So 10 to the minus 3.83, and we get 1.479 times 10, or I guess we should really keep sig figs, so well, we're going to hold on to a little bit more right now because we're not at the end of the question. So, but 1.48 is still holding on to one too many, but that should be fine. All right, 1.48 times 10 to the negative 4. All right, molar. Okay, so this is the concentration of the hydroxide ion. Now I got to relate that to the magnesium ion, right, using stoichiometry. So I have 1.48 times 10 to the negative 4 molar concentration of the hydroxide ion, and I had 2 hydroxide ions for every 1 magnesium ion. So I need to take that 1.48 e to the negative 4 divided by 2, and we get 7.4 times 10 to the negative 5 molar, and that is the magnesium ion concentration. Okay, and at this point we just need to take those numbers and plug them in up here. So that's 7.4 times 10 to the negative 5 times 1.48 times 10 to the negative 4 squared. All right, so 7.4 e to the negative 5 times 1.48 e to the negative 4th squared. And I get so going back to sig figs now, 1.6 times 10 to the negative 12. And hopefully we got this right. Ta-da. All right, awesome. So hopefully y'all are feeling pretty good with those types.